What we're going to do is welcome back to Mr. Morgan's videos, and we are going to do this math for chapter 15, I think. I don't think it's chapter 5, I think it's 15. All right, the first thing that you have is a 75.9 kilogram man is walking at a speed of 15.635. What is his kinetic energy? The answers must be in joules. Ladies and gentlemen, if you look, the formula for kinetic energy is here we go, 1/2 mass velocity squared. So that is 0.5 times whatever your mass is, velocity squared. This is what it's going to look like on a calculator. So if you have your calculator, you come over here. A kilogram is a mass, right? This is speed with direction, so we call it a velocity. And we're looking for kinetic energy. So here, 0.5 times your mass times velocity squared. And due to the distributive property, you can do either one anytime because it's simply a multiplication problem. So we got 75.95 kilogram. So you put that in. Or you can put 15.63 in, 15.63, square it, times, and if you want to, you can parentheses it, 0.5 times 75.95, and parentheses, equals. Edit, copy, paste that bad boy in there, and go to your second decimal. All right, number 2, what is this kinetic energy? Number 3, a kilogram has a kinetic energy of 19,000 joules. How fast is the cheetah running? Or in other words, what is his velocity? You look over here, you're solving for V2, right? So here, if you're looking for V2 and you've already got your kinetic energy, I know that's kind of a janky KE, so that would be kinetic energy divided by 1/2 mass, right? Would equal velocity squared, right? But if you took the square root of it, it would equal V. So here you got kinetic energy divided by 1/2 mass, and you square root it. That's how you do that. So coming over here, and you've got your kinetic energy. So I would put that in first. So that's 19,000. So for question 3, it would be second number divided by 0.5, first number square rooted. Okay, so you got 19,125, right? Divided by, and I always use my parentheses, 0.5 times 82, end parentheses, equals, and then I just hit that square root button. I wonder if that's right. I wonder if I did that correct. Because it's been a minute. So let's see if I did that correct or if I just got chubby fingers. And we're going to find this out because it'll give you the answers to everything. Oh, no. See, it was right when I did it because here I had, all I had to do was square root it. I didn't have to hit equals. So I got 19,000 second 125 divided by 0.5 times, what's his mass, 82. Then I square root it, and that's the correct answer. I don't have to hit equals. I put in 0.3 because I hit equals. All right. So on the third number, on the third question, it's simply second number divided by 0.5, first number square rooted. And then here's one. A 55 kilogram rock is dropped and hits the ground at a speed of 64 meters per second. Calculate the gravitational potential energy before it was dropped. Now guys, on here, there is the formula for this, and you guys have to understand, is kinetic energy equals potential energy. And they're asking for calculate the gravitational potential energy of the rock. But they're giving you a 55 kilogram rock hits the ground at 64 meters per second squared, right? Well, kinetic energy can be calculated by what? Just like in the first one, 1/2 mass velocity squared, right? And here it says calculate the gravitational potential energy. And the gravitational potential energy is potential energy equals mgh, which is mass times the acceleration due to gravity, which is 9.8 meters per second, times height. But you can't solve for that because you don't have anything in here except for velocity and mass. You don't have height. So on question 4, it's 1/2 mass velocity squared. And that's all you do. And if you look, here's our answer, right? So all you have to do is 0.5 times 55 equals times, what's our velocity? 64 squared equals. And then that equals that. Ladies and gentlemen, on number 5, a diver with a mass of 144 kilograms stands motionless atop a 3-meter high diving station. Calculate his potential energy. This tells you what to do. KE equals PE. Calculate the PE, which is mass times 9.8 times height, right? And then, so mass times 9.8 times height. Then use the square root of that to divide by mass. So we're going to do this, right? You're going to calculate PE and then square root it, and that'll give you the velocity because it's the same question. So let's take this. Question number 5. Calculate the PE. So you got 9.8 times mass times height, right? But this is not the same as this because you got to what? Square root it? Oh, wait. Then use square root of PE divided by 1/2 mass, right? And then you could divide that by 0.5. I wonder if this is going to work. No, it's got to be like 144 times 9.8 times 3 equals. So that is the PE. Then you use the square root of PE divided by 1/2 mass. So if you've got that, and we got to do this numerically, so if we divide that by 0.5 times 144, and then you square root it, it's still not right. So this is where a lot of people get into problems, because you have to calculate this. When you calculate PE, use the square root of PE divided by mass. So ladies and gentlemen, you have to use the parentheses, because we tried it now twice and the calculator is not